Okay, hey, welcome everybody. Today we're going to cover, or tomorrow in class, we're going to go over some Algebra 2 review, cover properties of functions, and first thing I want to start off with is parent functions. Remember, a parent function is the simplest type of an equation or function, simplest type of a function for a given family of functions, okay? So this is basically a linear equation, but this is going to be called a constant function where just f of x equals c. Let me just zoom in a little bit. Okay? So again, remember, a parent function is the simplest type of function for a given family of functions. And what would be a family of functions? The linear family, the quadratic family, the cubic family, okay? So here's the constant family, and here's my function. It's f of x equals c, okay? Look at my graph. Let's talk about domain. The domain is all my inputs. Notice I have a graph that spans all the way across here. So you notice I've got inputs all the way, so the list of inputs is endless. This graph goes from negative infinity to positive infinity, okay? So notice, but my outputs, when I look at the y-axis, I just have this value 2. In this case, I'm just going to call it a constant. Okay, so when I look at domain, list of inputs, I'm going to look at where's my graph span from left to right on the x-axis, horizontally. This graph spans from, basically, let's make a arrow here, negative infinity to positive infinity, okay? All real numbers is my domain, but notice my range is, that's a y, by the way, y equals c, or constant, in this case 2. So when I look at my range, I'm looking up and down. What's my output values span? What's the span from bottom to top? And it's basically just a constant. All right, so here's my linear function. The parent function is, the simplest form is f of x equals x, or, you know, one you're more used to maybe, comma, y equals x. All right, this is the simplest form a line can get, right? There's no mx plus my slope is 1 and my y-intercept is 0, okay? Notice, from left to right, this graph goes from horizontally, this graph spans from negative infinity to positive infinity, and vertically for range from negative infinity to positive infinity, okay? Notice my domain and range are all real numbers. That's that R is all real numbers, all right? Here's a quadratic equation, the quadratic family, okay? Function f of x equals x squared. That's as simple as it gets. There's no 3x squared plus 2x plus 1 or anything like that. Okay, notice, when I look at this, there's no restrictions on what I can put in for x. We're going to square, I could put in anything. There's nothing that's going to hurt me, okay? So it's all real numbers, but look at my range. Since everything I put in, including negative numbers, gets squared, I only come up with positive numbers. So what's my range? Y equals 0 or greater than or equal to 0, okay? So this is getting wider, so I go from negative infinity to positive infinity. Even though you don't see it on the graph, this is getting wider and this is getting wider to negative infinity and positive infinity. That's horizontal span of what my inputs are on the x-axis. Vertically, though, I'm from 0 on up, okay? Here's cubic. This is what a cubic function looks like. Remember, a negative times a negative is a negative, and a negative, so remember, we can take the cubic root of a negative number, okay? We can take, unlike a square root, just think, there's something to think about. We can take the cubic root of a negative 8, so we can have negative numbers for a domain of a cubic function. That would be negative 2. Okay. Notice this graph also horizontally, this, even though it's very narrow, it's still getting wider on both sides. So it spans from left to right, from negative infinity to positive infinity. And my range is also from negative infinity to positive infinity. All real numbers for domain and range. Okay, the square root function. Okay, again here, I can't take the square root of a negative number. This has to be 0 or greater. And this is from 0 or greater. Notice my range is 0 or greater. Okay, absolute value. Okay, there is no restrictions on what I can put in here for x. Notice I can go negative, negative. So here again, here's a great example of where my graph goes horizontally. My domain, my list of x inputs is mapped out from left to right, from negative infinity to positive infinity. But my range, list of outputs, I look vertically on the y-axis from 0 on up. Hence, my range is y is greater than or equal to 0. My domain is all real numbers. Here's our exponential function. F of x equals b to the x power. Okay? And, or it could be 2 to the x power, but some base to the x power, 2e. Okay? Notice, again, I can plug in anything for x. So this graph spans from negative infinity to positive infinity, all real numbers, but the output is y is greater than 0. It never touches 0. That's a horizontal asymptote. The logarithmic function. I'm not sure if they really consider this apparent. I'm putting it down here just because I wanted it following the exponential functions. Notice, remember, my domain and range should be flip-flop. Okay, notice this log of x, this x has to be greater than 0, so that's my domain. And you look at the graph. Where's this graph start? It never touches 0. The y-axis is a vertical asymptote, and this goes from 0 to greater. Okay, so x has to be greater than 0. But notice this graph continues to get taller and taller and taller, although it's very shallow, but it goes from negative infinity to positive infinity. All reals. A couple more. We have two rational functions. This is 1 over x. Notice I have all these values except for I've got an asymptote here. Notice how this hits that invisible wall and this hits that invisible wall. I can't have a 0 in the denominator. Okay? X can't be 0. All real numbers, but x can't be 0. But notice my range is the same also. Negative is also similar. Negative infinity to 0, not including 0. So my range is from negative infinity all the way up, but not including 0. So basically, y is less than 0, and also y is greater than 0. Okay, from greater than 0 all the way up to infinity. So I could just say y is greater than 0 and y is less than 0. I have a horizontal asymptote and a vertical asymptote here. Here's the y over x squared parent function for a rational quadratic. I guess I'm not sure what they call that. I forgot, to be honest with you, but that was a parent function in Algebra 2. Okay, vertical asymptote, domains everything but x equals 0. My range is, doesn't matter which side you look at, all my y values are greater than 0. And here's the greatest integer function. This is a very hard one for me to remember. It's always the greatest integer less than or equal to x. So, one second. Hey girls. Anyway, sorry, I thought I had an interruption. So the greatest integer, I plug in all these values of x, 0.1, 0.2, 0.3. What's the greatest integer less than or equal to x? Well, 0.7 is not an integer, so what the greatest integer less than or equal to x? Well, it have to be I'd have to go less than that. 0.7 would be 0. That's the greatest integer. Notice this is an open circle. So then I go up to 1. Notice I come in here from 1 all the way to 2, 1 including 1 but not including 2. Notice the open circle. 1, 1.2, 1.3. What's the 1.3? What's the greatest integer less than or equal to 1.3 or 1.7? It's 1. So notice all these inputs from 1 to open circle 2 are going to be on this 1. The greatest integer less than or equal to 1.9 is 1. So it's the straight lines, okay? All right, so the domain is all real numbers. Notice that even though I have an open circle here, I have a closed circle here. Open circle, closed circle. So I still have all real numbers, but my range is all integers, okay? Those are all my parent functions, okay? Here's a follow-on worksheet. Here's an example of how could I configure domain. These arrows indicate going to infinity, negative and positive infinity. So I'm basically going from negative infinity all the way up to 2, and it looks like 2 is included. Okay, and then I'm going to union with this set. I have no graph anywhere in here, so my graph picks up again here at 2, and 2 is included all the way to positive infinity. My range is easy. I don't care which which part of the graph you look at, I still have outputs from negative infinity to positive infinity, all real numbers. So see how I went horizontal to track my x's and vertical for my horizontal for domain, vertical for range, looking at the graph. Okay? And we'll take a look at solving for, let's say, domain. Just asking for what, so for this equation here, this would be, let's see, spin the zoom in. Find one. Let me do this other one because some of these are kind of... Well, let me just tell you this. When I set these things up, remember, my domain for an exponent, right here, this can be negative. It can be all... This can be all... Anything, this can be all... Anything I plug in can be all real numbers. So it doesn't matter. My domain is still all real numbers, even though it's 2x plus 1. I can take the cube root of a positive or negative number, so this can be all real numbers as well. Okay? Same thing here. My domain can be all real numbers. Okay? Let's try, if you can see this right here, log of 3x plus 4. Now here's something we'd have to solve for. Remember, this whole entity here has to be greater than 0. So I would say 3x plus 4 has to be greater than 0. I can't take the log of a negative number. So minus 4 minus 4, 3x needs to be greater than 4. Divide by 3, and then x needs to be greater than 4/3. That's my domain. X, all my x values from 4/3 on that number line, open circle to the right would be my domain. Okay? All right, there's a couple of those problems that we need to solve just for, and we'll go over them in class. And I think I'm missing one of those. Here's another good example here. How much time do I got? 12 minutes. So anyway, here's an example here where I don't care about my numerator being 0. I do care about my denominator. So I would set this denominator x squared minus 4, and I'm talking about domain. This cannot be 0, right? So I'm just going to set what makes it plus 4 plus 4, x squared equals 4, and you square root both sides. So x equals negative 2 or plus 2. Those two numbers we can't have, so I end up saying, hey, we can't have that. So that would be, my domain would be all real numbers for this problem right here. Okay, that's all I have. We'll get into, hopefully finish this up tomorrow, and then the next day we're going to get into odd and even functions. Okay, all right, have a good Sunday.